Like I said, this right here, guys, decimals will be pretty important for you today in terms of what we're going to do. And we'll talk about what this is going to look like. But our job today is to solve quadratic equations by graphing. And that's just the question today. How can you use a graph to solve a quadratic equation in one variable? So goals, really we're going to start looking at solving quadratic equations by graphing. We're going to use the graphs to find and approximate this will be a biggie right here, zeros of functions. We'll also look at some real life problems using graphs of quadratic functions today. So I think that once you see the first problem, you're going to catch on really quickly. Okay, quadratic equation, kids. It's a nonlinear equation and can be written as the form ax squared plus bx plus c equals 0. What form is this ax squared plus bx plus c? Standard form. So an example, we're looking to try and set standard form equal to what value, kids? That's our job today. So an example might be like 6x squared minus 8x plus 4 equals 0. Our job is to try and write an equation of standard form equal to 0 and then use that to help us solve, all right? Now, another term that we're going to have is x-intercept. X-intercept, pretty much self-explanatory. It's the point where a graph crosses the what? So let me just say this right here. If I draw a quadratic, how many x-intercepts are for that graph? 2 of them, right? 2 of them. One is right here. The other is right there. Okay, those are x-intercepts. All right. Another term we're going to look at is root. And a root is a solution of an equation. Okay. And then likewise, down here is 0 of an equation. X value where f of x is equal to what? 0. And a solution or the what? All right, here's what I want you to understand right here. These three terms right here, these all pretty much mean the same. They pretty much mean the same exact thing. So if I say, what's the x-intercept of the graph? That's the same as saying, what is the root of the graph? Or what is the 0 of the equation? Here the terms x-intercept this section, root, or 0, just understand they all mean the same thing. You bet. Okay. Well, let's jump into this, kids. Solving quadratics by graphing. Step 1. Won't you read that one for me? I've got it. Write the equation in standard form. Ax squared plus bx plus c. We want this to equal what value, kids? 0. Okay. It says step 2. Graph the related function. Y equals ax squared plus c. And step 3. Find what?
X-intercepts.
If Rn. Okay, the solutions are roots of ax squared plus bx plus c are the x-intercepts of the graph. So let's just look at this right here, kids. I'm going to jump into decimals. First things first. I want to solve this by saying x squared plus 2x equals what value? 8. Now I'd like to solve this by graphing, but I can only solve this by graphing according to what this core concept is by making sure that we have standard form equal to what value?
0.
So I've got to make one side become 0. So on the right side I have this equal to what value here? Well, what's it equal to? 8. How can I make this equal 0 right here? What would I have to do to both sides, in other words? Yeah, so if I minus an 8 on the right, I better darn well do it to the left. Okay, so what we end up with here, kids, is we have an x squared plus a 2x minus how much?
8.
Equals what value now?
0.
0. Okay? So this is the part where you say, all right, I have my standard form of a quadratic equal to 0 now. So what we're going to do is we're going to jump into decimals. And we're going to say, all right, I'm going to type in, oops, I don't want the caps lock on, x to the second. What was the rest of it, kids? Plus 2x. Now we've looked at finding zeros algebraically here, but guys, what we're looking at now is this. When we graph this right here, we're looking for the 2 points that are considered my x-intercepts. Isn't this my x-axis right here, kids? Okay. What do we get for values right here? What are the x values of those points to make our y value 0 here?
-4 is
-4 and what? positive 2. So the solutions of that are negative 4 and positive 2. So when I do that like that, I'm going to make a sketch of our graph in our notes so we identify what's going on. We get a graph that looks like this. Came through negative 4 and positive 2 right here. So I would say right here, when we solve this, x would equal what values to make this equation true? Well, negative 4 and 2. Check it out, kids. Plug 2 in for x up here. What's 2 squared? 4. What's 2 times 2?
4.
What's 4 plus 4?
8.
Does that make that statement true, kids? Okay. What's negative 4 squared, kids?
16.
16. What's 2 times negative 4? Negative 8, right? What's 16 minus 8? Works again, doesn't it? Okay, so my solutions are x equal negative 4, x equal 2. Again, rewrite it so it's in standard form, such that that standard form is equal to what value, kids?
0.
0. Plug that in, and then you're simply looking for the x-intercepts. That's all you're really doing. Okay? Anybody need more time with this first page right here? Feeling pretty good about it? All right, let's take a look at page 2 here, friends. Ooh, another one. Solving a quadratic equation. What's this say right here?
Solution.
Hey, you guys help me rewrite this. Can I just plug it in right now, or do we need to maybe rearrange some things before I can proceed? Okay, what do you want to do to both sides, maybe? Yeah, maybe we should add a 4, because that would allow us to make the right side equal to what value? 0. Now, is this plus 4 here on the right? I need to do it to the left. So what's standard form going to look like on the left, kids? Yep. Excellent. X squared plus 4x plus 4, and that's going to equal what? Okay, so now that I've got that equal to 0, let's go check this out. Maybe you guys type it in and tell me what you have. And I'll do the same thing up here. Ooh, what are you guys finding out? How many x-intercepts are there to that problem? What point is the x-intercept?
Negative 2.
Negative 2. That same point is also the what in my parabola? The vertex actually turns out to be the only solution there, okay? So in this case right here, we would say there's only one solution, and that one solution happens at x equals what value? X equals 2 there, yep. Okay, so do I need to draw a sketch of this again for you, or is this making sense so far? Okay, so solution would be, what was it, 2 or negative 2? I can't remember.
Negative 2.
Negative 2? All right. Well, example 3, kids, what's that say to do? Okay. We've gone from a situation on the first page where we had, how many solutions, kids?
2.
2. We looked at an example right here where there was actually one solution. Can somebody maybe describe to me before we even do this what it means to be no real solutions? What do you think, Logan?
Wouldn't it be above the x-intercept?
Yeah, it might be all the way above the x-axis or all the way below the x-axis. It might not even cross the x-axis at all. So let's see if this is true. Guys, what would be the easiest way to make one of those sides equal 0? Couldn't I add x squared to both sides? Would that be okay? All right, so I'm going to add x squared to the left. I'm going to add x squared to the right. So on the left-hand side, kids, what does this negative x squared and positive x squared do? You say cancel, so cancel really can be, yeah, goes to a value of 0. And then what's my standard form going to look like on the right side, kids?
X squared plus 4x plus 8.
All right, so let's take a look at this here. I'll go into decimals again. We'll type in x squared plus 4x plus 8. There it is, kids. And the question becomes, where does it cross the x-axis at? And you would say, well, Parson, it doesn't. Okay, and if it doesn't cross the x-axis, is it ever equal to 0? So in this case, you would say, since it doesn't cross the x-axis, there are no solutions. There's no solution to this because this doesn't cross the x-axis. So this does not cross the x-axis. So what's that mean, kids?
No real solution.
So there is no solution. And I'm going to write it as no real solution because it turns out there's actually imaginary solutions, which we'll talk about way later in the chapter. But there it is, kids. This does not cross the x-axis, therefore, no real solution. All right, how are we on this page, friends? I have a question for you. I told you that finding the solutions or finding the zeros or finding the roots mean exactly what? But it only works if your function equals what value? Now, in this one right here, it says you have a graph, f of x equals negative x squared plus x plus 6 is shown. It says find the what? Well, if they give you f of x like this, kids, you simply just change f of x equal to what value? Okay, so you guys, you tell me, you guys get into decimals right now. First things first, when I say find the zeros, you want to rewrite it so that 0 equals your quadratic. Am I good to go the way I've written this right now, kids? Okay, when it says find the what?
0.
Of your function, you just let your function equal 0. My function is this quadratic right here in standard form, set it equal to 0, and you're on your way. So you guys hop into decimals, you tell me what you're getting for your intercepts. Maybe there's no solution here, I don't know. Make sure you agree. What are you typing in there? You're typing in negative x squared plus x plus 6. What do you guys get? Now just click on your blue graph and then go to the little dots there and it'll tell you negative 2 and what? Negative 2 and 3. Very good. Are you guys all getting negative 2 and positive 3 when you graph that?
Yeah.
Anyone that's not? Thumbs up if we're all good right now. Good, Gracie? Okay. All right, so what were my values again? Lex, what were they again?
Negative 2 and 3.
Awesome. Guys, I told you this was pretty easy. How many are like, yeah, you weren't lying to me, Parson? Pretty okay? All right, let's take a move here. Third page, friends. Oh my gosh. Approximating what, kids? Now, sometimes when we do this, kids, sometimes we don't get the nicest numbers in the world. But it says the graph of f of x equals x squared minus x minus 5 is shown. Actually, it's not shown. We're going to show it here. It says approximate the zeros of f to what? This is what's cool about graphing here. You get a pretty good idea of what you need right here. So, kids, help me out. What was that? X squared minus x minus 5. Was that right?
Yeah.
Back up on this. You said minus x minus 5?
Yeah.
Okay, now sometimes we get some pretty ugly decimals for this, but you know what? Decimals is a pretty powerful tool. It allows us to say, well, I think one's here and we think one's here. Now to the nearest tenth, looks like this value would be what?
Negative
1.8, and this would be about 2.8. Okay, you guys see that? We're not always going to get the nicest values in the world. So negative 1.8 and 2.8, I would say nearest tenth, all right? All right, well, solution. What were they again, kids?
Negative 1.8.
Very good. So let's put this into action right here, kids. So the soccer player kicks a ball 2 feet above the ground with an initial vertical velocity of what? Okay. The function h equal negative 16t squared plus 60t plus 2 represents the height in feet of the soccer ball after t seconds. Okay? So part A says find the height of the soccer ball each second after it is. Okay. Let's make a little table here, kids. I'm going to need your help. I'm going to go X. No, I want to go T and I want to go H. Time T, time H. And let's just maybe say, let's go 0 to 5 maybe. Time 0, time 1, time 2. I think I've got a typo in part B. We'll come back to that because it says the same exact thing as A. All right, kids. A couple different ways I can do this. You want the easy way or the hard way? The easy way? All right. Can I tell you what the hard way would be first? Is that okay? The hard way would you just put all these values in. So like if I put 0 in, if I put 0 in here, what value do you have? If I put 0 in for this whole function, what would you get out? 2. Okay, that would be the hard way. All right, let me show you the easy way. Okay, if you come in here and type in, now I'm going to type in where there's a t, I'm going to type in an x, but what was it, negative 16, where it was t, I'm going to use an x squared. Was it plus 60t?
Yeah.
Now, I want to show you guys something. Do you guys know how to change the zoom on your Desmos to make that fit your screen? Listen carefully on this. I don't like the way this. You can zoom out a little bit as much as you want, but I don't like that. Okay, here's an easy thing to do. If you come to and put your cursor right here by the x-axis, and then hit the shift button. Okay, see how my cursor's at the x-axis down at the bottom? Right down here. If you do this and hit and hold the shift button like this, see how that changes? Hold the shift button, you can kind of compress it or stretch it. If you push up and down like that, it will stretch it to make it fit your window better. Okay, so bring your cursor to the x-axis, hold shift, see how that goes to an arrow up and down? Then you can just use 2 fingers to swipe up or swipe down to make that fit your graph better, or your window better, I should say. Are you guys getting that? Okay, so here's the easy thing to do. At time 0, what's the height? Okay, we'd like to follow this around. Then to get to time 1, I'm just going to click on the graph and go up to x equals 1 second about. What's the height at 1 second, kids? 46. Okay, so let's go write that in there. This would be 46. Okay, then we want the height at time 2. So let's follow this over to about time 2. Let's see if I can get that to be exactly 2. Oh, come on. What's it say?
58.
Height is 58 now, isn't it? And then I want time 3, is that correct? So 3 is right about, oh, I was right on it. What's the height at 3? 38. What's the height at 4, I wonder? Okay, it does, so we get to this right here, it's back to the ground here, isn't it? At time 3.78. So do I need to put a height in at 4? No, because at 4 seconds it's already returned to the ground, hasn't it? Okay, so now I've got a typo in part B. Give me 1 second, kids. Okay, part B should say this. Let's change this. Text box in here. All right, so what I want you to type in here says estimate. Oh, that's kind of small. Estimate when the ball is at 40 feet. Well, kids, when does that time happen? What was our height at time 0? What was our height at time 1? 46, right? Now, is it going to be closer to time 0 or time 1 when we're at 40 feet in the air? Closer to time 0. Here's how this is working, kids. I'm going to show you a shortcut. I think that this is pretty swift. Decimals is so cool. We want to estimate the time when the ball gets to what? 40 feet. Okay, here's what happens, kids. In decimals, if I would do this, I'm going to change this a little bit so it fits better. I'm going to hit and hold shift and stretch this out a bit. What you can do right here, guys, is this. First of all, my height is like a y value. You agree that this down here is like my time it takes, and then the y-axis represents a height right here? Would you agree with that? Okay. I'd like to know the time it takes for the height to get to be y equal 40. So I'm going to type that in right there. I'm just going to type in y equals 40. Guys, this blue line represents the height of 40 feet right here. And it looks like to me it gets to 40 feet at what time? How many seconds did it take to get to 40 feet? Okay, and then it also gets to 40 feet, but it also returns to 40 feet right here, doesn't it? So if I would type in that height, y equals 40 right there, how many different times is it at 40 feet in the air? 2 different times. One is on its way up, and another time is when it's on its way down right here. Okay, so what 2 times does that happen? Looks like 0.8 seconds, and what else? 2.9 seconds. Okay, so what I might do is this. I might just make a sketch of our graph right here and say, well, in part B, what's really happening here is this. We have a graph that looks kind of like this. We have a graph that kind of looks like this. We drew a height through here at 40. This line represents 40 feet. And that height happened at 0.8 seconds. And at, what was the other one, 2.9? Okay. So now, using our graph right here, it says after how many seconds is the soccer ball 40 feet above the ground? So it's 0.8 to what? 0.8 to 2.9 seconds. It's above 40 feet, right? So you could say, using the graph, after how many seconds is the soccer ball 40 feet above the ground, you would say it's at 0.8 seconds to 2.9 seconds. So if another question came in and said, for how much time is it above 40 feet? Well, what's 2.9 minus 0.8, kids? Be above 40 feet for how long? You'd say 2.1 seconds. Okay. All right, guys, really, nothing magical here. You're looking for intercepts, aren't you? Are you guys comfortable using decimals to make that work? Try to get standard form equal to what value, friends? 0. Okay. All right. Here's what I'd like from you guys. You got a question?